I've talked about factorial notation in the previous video, or factorials. So factorial, for any integer n, the product of all positive up to and including n is noted as n factorial. So if we multiply all numbers 1 through n, all integers 1 up to n, so 1 times 2 times 3 times ... times n minus 1 times n, this is n factorial. But universally, how do we think of it? Well, we count down. So n factorial is n times n minus 1 times n minus 2 ... times 2 times 1, all the way down. And then by definition, if you ever run into this scenario, by definition, 0 factorial is equal to 1. So let us start with our first factorial. This is 5 factorial. And it is a button in your calculator for sure. If you hit math, the math button in your calculator, if you have a Texas Instrument, and you go under prob, you'll see the little exclamation mark as the 4th entry in your menu. So to do 5 factorial, we simply put 5 and then enter this symbol and we'll get it. But evaluate 5 factorial. 5 factorial means 5 times 4 times 3 times 2 times 1. And 5 factorial, you can do it in your head, and that's fine. But 5 factorial is equal to 5 times 4 is 20 times 3 is 60 times 2 is 120. Now, where has this place in permutations and combinations? Now, how many different 6-letter words can be created using A, B, C, D, E, F? So now, basically, how many different arrangements can be made if we scramble these 6 letters? So, 1, 2, 3, 4, 5, 6. I have 6 different letters to scramble. And in my first place, there are 6 choices. My second place, there's 5 remaining letters. My third place, there's 4, 3, 2, and 1. In other words, 6 factorial. And 6 factorial is equal to 720. Fair enough. I used the fundamental counting principle to help me out to determine the number of arrangements, and I so noted that we're going to use, or this presented itself in factorial notation. So let's move on to the next example. How many 2-letter words can be used with the letters A, B, C, D, E, F? Great question. So 2-letter words, so really I have 2 decisions to make. What goes in the first letter, what goes in the second letter. And I have 6 choices, so I have 6 choices. And then once I use up one of those, there are 5 remaining. So really there are 30 different arrangements. Now, just an aside, the wording here, permutation, as we'll hopefully flesh out later, order matters. And that is a real math terminology. Oh yeah, order matters. But really, what we're trying to say is, if you have 2 elements, A and B, A, B is different than B, A. So you have 2 of the same elements, but they're in a different order, so order matters. So that's important, and that's what separates a permutation from a combination. So right now we're doing permutations because order matters. Second thing is implied in the question is that you cannot use the same letter twice. So we had 6 letters. I could not choose A and A. Why? It was just implied in the question. Perhaps it should have been explicitly stated. But regardless. Challenge. Write the above using factorial notation.